with Unity's VFX Graph, you can have millions of particles at the same time on the screen, and now that's possible because VFX Graph creates particles that are simulated on the GPU, as opposed to the inbuilt Shuriken particle systems, which are simulated on the CPU. Since doing calculations on the GPU is much faster, you can create a lot more complex simulations with a huge amount of particles. Something that makes VFX Graph very powerful is that it's built using a fully node-based tool. And if you're familiar with shader graph, then you must be very familiar with this interface too. And that really means that you can add, delete, edit nodes to make cool looking particles. This also means that you have a very powerful artist-friendly tools to create some amazing effects. Another cool thing that is that external assets such as point caches, vector fields, sign distance fields, or SDFs can also be used to create some visually stunning effects. So let's dive right in. No more slides. Let's do some demonstration, right? All right. So what I have here is today is, of course, Star Wars Day, and it's kind of criminal if I don't have a Star Wars themed VFX demo. So I put together something that's pretty cool specifically for you guys. These are, of course, I don't know, what do you call them? Wookiees? No, just kidding. Stormtroopers. And they are shooting some blasters. And of course, not necessarily, so you need to be using some of your imagination on them shooting, because I couldn't really get them to animate because I just got them off the internet. But you got them shooting some blasters, plasma beams from their blasters, and they're shooting into an invisible wall here, and they're trying to just get out of this ship. So go wild with your imagination. But what we are going to be doing today is especially this part where we are going to be simulating the blasters. So blaster effects are a great way to teach VFX Graph, since it teaches you how to create all kinds of other effects as well. We'll also be talking about GPU events, which are very useful to string effects together so that different effects are spawned one after the other. We'll split the blaster effects itself into three parts. We have the initial blast, which you kind of see here, which is generating that intense plasma energy. Then we'll have the plasma beam itself. And then finally, we'll look at explosions. So before I begin, let me also just open up the hub so that I can show you something. I should have opened it up earlier. Just a second. There you go. All right. So first thing you need to make sure before you start using Unity VFX Graph is that you should be running Unity 2018.3 or later. So you're going to be creating something new. Make sure that you're using 2019.3. You should also ensure that you're using either the high definition render pipeline or the universal render pipeline. Both, these are the render pipelines that support VFX Graph. Go back in here. So as you can see, I'm running 2019.3. First things, make sure that you have the VFX Graph installed. So open up the package manager, go under all packages, and make sure that you have the VFX Graph installed, which should just be down here, all the way down. VFX Graph. It's usually auto installed when you use HDRP. And if you have that installed, we are now ready to use VFX Graph in our project. Another thing that you also want to do is, in order to start creating, I'm going to just use a existing scene. So I'm just going to open up this scene. It's just an empty scene. Just has these stormtroopers all lined up. So let's start creating some VFX Graph. So to do that, I'm going to go to my project window, right click, create visual effects and visual effect graph. I'm going to call this graph. because why not? VFX Graph. And let's just drag it right into the hierarchy. So one of the cool things about this is Unity has automatically created a game object with this effect, and it has the visual effect component attached to it, which references our VFX graph. So right away, you can see that it's generating some particles over here. We also need to go to Edit, Preferences, and go all the way to Visual Effects, and make sure that you have this experimental operators and blocks checked, because we'll be using this since this is the one that enables us to use the GPU events that I was talking to you guys about earlier, which strings together different VFX events one by one. All right, so I'm going to double click VFX Graph, and that should open up the VFX editor, which I have it opened already. So just take a bit of time. So as with any other window inside Unity, you can dock it anywhere in the UI. So you can dock it here, anywhere you want. But I'm going to dock it to the side so that you can see it better. And like I said earlier, if you have used the shader graph, you will notice that it looks a lot similar. So on the left-hand side, there is a blackboard, and on the right-hand side is a huge space where you can add nodes and edit the VFX graph itself. Navigating is also very similar to shader graph. You can use the middle mouse to drag, or you can also do the same thing with the Alt and left mouse button. You can scroll to zoom using the mouse button. And if you want to focus on some node, you can hit on F by selecting the node. You can also click, select A, the A key on your keyboard, and it'll just show everything in your shader graph. All right, I'm seeing some chat message. Okay, audio, great. Just checking the chat because I just want to make sure that audio is okay. Cool. So when you, what you see here is the structure of a basic particle system. It contains a chain of contexts, which are each responsible for one aspect of the system. So let's go through it one by one. On the top, we have spawn. In this context, you can tell the particle system how many particles we want to spawn and in which way we want them to go. That is, do you want them to be constant or do you want them to be in bursts? The next up is Initialize Context. The Initialize Context allows us to set up some initial values for each particle emitted, which also mentions like how long does this particle live and even what color does it spawn with and all of those options. We can also set the capacity of the particles, which essentially means how many particles can our system handle, or even you can also set the bounds for those particles. We can then change the properties of a particle, such as position, rotation, size, and so on over time. To do this, we are going to be using the update context, which is very similar to your update method if you're familiar with the mono behavior part of C# scripting. You can add forces such as gravity or torque to change those values within the update context. And finally, how each particle is rendered is defined in the output context, as you probably already guessed. We can choose from points, lines, quads, or even meshes or decals to render out each individual particle. Each section in this context that you see here is called a block. This is a block, this is a block, this is a block. So orient, set size over life, blah, blah, all of those is a block. Blocks are small chunks of logic that can be added to the context to do a very specific task. So take, for example, set lifetime random, right? We can use this to tweak the behavior, or if you simply remove it, it will then not affect our system. To create a new block, simply hover over a context and hit space. And here you can see different categories for each types of blocks that we can create. Now this menu is context aware and will only present options that actually make sense in this context. So for example, in the update particle, you've got to hit space Let's add some gravity. So I can just search for gravity in my search bar. And as soon as I click gravity, you can now see that my particle is now falling down because gravity is now affecting it. You can see that our effect automatically updates because our VFX graph is set to auto compile, which you can see on the top over here. One thing to note is that values that you change the node will immediately update, which means if I deselect auto compile and not make it auto compile, any changes that I make to the values over here will anyway be affected. So if I make this positive 19, even though I don't have auto turned on, it's still going to affect that. But if I delete this block by just clicking on the delete button, you'll notice that gravity is still being updated, but because it's not auto compiled, it's not going to take effect of that particular block. But if I click on compile, it'll automatically now take that into consideration. So you can, of course, like manually compile it, or if you just click on auto, it'll always auto compile. To help you with some basic effects, Unity provides some inbuilt graph right inside the Unity VFX editor. You can access them by right-clicking in the editor, click create node, go to system, and you have some default graphs that help you get started. So for example, if I select simple heads and trails, it'll automatically create a VFX graph which has that cool looking effect. So there's two graphs here, so that's why you're seeing two effects. But if I delete the other one, select them all, delete them, you'll notice that now this is an inbuilt effect that's part of the VFX editor itself. So this is pretty much how I usually work. I start off with a VFX graph that kind of looks like what I want to be doing, and then make modifications to it rather than starting something from scratch. There's a lot more. My favorite one is going to create node, system, and I'm gonna select a swarm particle system, which is usually what you see in a lot of demos. So woo, cool looking particle system, and all it really needed was just one set of blocks over here. All right, so I'm gonna delete all of these, so because I'm gonna start something from scratch. All right, so like I said earlier, this entire talk is divided into three parts. Having the blaster, the flash of the blaster, and then the plasma beam, and then the explosion of the particles itself. All right, so we'll start with part one. So I'm going to create a node, I'm going to create a system, and I'm going to create a simple particle system. That's just a basic particle system that I had earlier. So to create the flash, you first of all don't need this many particles. So I'm gonna, because the flash is just a flash, so instead of having 16 particles as a spawn rate, I'm gonna change it to 1, which means I'm only going to be generating 1 particle at any given point of time. Secondly, I also want to make sure that when I have it over here, the lifetime of the particle is just too much, because the flash is just going to be a flash. It's just going to like go bam, flash, and then go away. So I'm going to set the lifetime particle, which is in seconds, where it goes from 1 to 3 randomly. I'm going to change it to be about 0.1 and 0.2, which means it's going to be more like a flash. It's just going to flash and then disappear. I am also going to, just looking at chat, you click on the bottom of the flag. All right. And I'm also going to set the random velocity, which is being generated over here, to be, you know, I don't really want this to move at all. So I'm just going to make it all 0. I'm going to 0 it in all directions, so that it's just literally standing there and flashing. That's pretty good. Looks okay. Let me just also turn off the blackboard for now so that I can see the graph a lot better. So I'm going to turn off the blackboard, which I'll talk to you about what the blackboard exactly is in just a little bit by clicking on this blackboard button. Cool. All right, so I have the I've set the lifetime, set the velocity. Now what I'm going to do is flashes usually or start off small and they become bigger as the flash flashes. So I'm going to change the size of this flash over time using update particles, because update particle context is what you want to be using when you're changing any values over time. So I'm going to click on space. I'm going to add this block called add size. And you have a number of options where you can change the sizes over life, over speed, over randomness, over a curve. But for now, I'm going to change it to add size over life. And this has a sample mode where you can change it over life. And I'm going to change the size of this by clicking on this graph. And I'm going to change the size so that it becomes a little larger, not this big, but slightly larger. And then it dies very quickly because that's pretty much how flashes work. I'm going to set that up over like that. And finally, I'm going to go to my look because I don't really like the default look because you have a main texture that is a default particle. Doesn't really look good, but we're going to kind of stick around with it because there's a trick that I'm going to use to keep the default particle at the same time, not really look at it. First off, it automatically always faces the camera plane because this is a quad. So regardless of which angle I'm looking at, it's always going to be facing the camera. And we already set the size over life. You can either set it in update context or also set it up in the output context. We already set it up over life, so I'm going to delete that. And I'm going to set the color over life to be not color over life, but more just a color. So I'm going to delete that context. Click on space, and I'm just going to add a color. This color, I'm going to make it more yellowish. So I'm going to select this color selector. I'm going to open up this palette, make it more yellowish. You'll notice that it really doesn't show up as brightly as we want. In order for you to show this brightly, you got to increase the intensity of that of that color. So if I change the intensity, you'll notice that it looks a lot more like a flash. Now, if you're doing this and if you don't really see this intensity moving up, that's because I also added a post-processing volume. You go to the hierarchy, I click on post-process volume, and I go to my inspector. I've added a bloom post-processing effect to it. So the more bloom I add, the more intensity it increases. Bloom effect, for folks who are unaware of it, it just takes the color and then adds a little bit of brightness around it. And it's great to add effects like a hero entry effect or even showing this kind of a bright flash. I'm not going to go through the post-processing volume because that is a separate topic on its own, but I just want to mention that I added it. So now that I've increased the intensity of the color, you can see it a lot more better. And the default particle texture really doesn't show up at this point. So I'm pretty happy about it. So that's the first part. Now that we have all of this set, I'm going to right click on this entire system. I'm going to name the system Flash, so that you know what is the system all about. All right, so the next part is the most interesting part, which is the blaster beam itself. In order to create the blaster beam, we are going to be using GPU events, which chain different VFX effects together, or VFX effects? No, just VFX together. Yeah. So I'm going to go to my update particle, click on space. I'm going to search for GPU. And there are 3 events that are available. You can always trigger the event. You can trigger the event on die, or you can trigger GPU events over time. At this point of time, I really want to have a trigger event on die so that as soon as the flash is over, I want the blaster beam to just kind of blast out. So I'm going to space GPU trigger event on die. So that's going to create this event. And this GPU event has a count on it, which talks about how many particles do I want to generate as soon as this system is done with its death. I just want to create one plasma beam, so I'm going to leave the count to 1. I'm going to select this green circle, bring it out, and it's going to create a context, a GPU event. And this event is very similar to your spawn context itself. So I'm going to create another set of nodes. So I'm going to drag it out, create initialize particle, drag it out, create an update particle, and I'm going to drag it out, and I'm going to create an output particle, very, very similar to what we had earlier. But instead of creating a quad particle, I'm going to create a mesh particle, because why not? The plasma beam itself needs to be more 3D. So I'm going to create a output particle mesh. You of course have like lit mesh and distortion mesh, but I'm just going to be creating an output particle as a mesh, rather, which makes 3D rather than make it a quad particle. Create a mesh. And now we have another system which looks pretty similar to our previous one, and we're going to be working around with this one. All right, to begin with, we want to have the plasma beam be generated in the exact same position as the flash itself. So in my initialize particle, I'm going to select space, I'm going to hit space, and I'm going to add a block called inherit, which means I want to inherit the old position, or inherit the position of my previous event. So I'm going to inherit the source position, which means that this event is going to be generated, as you can already see here. There's a capsule that you see here. That's because the mesh has a default mesh of a capsule. And you can see that automatically the capsule got generated in the same space as the blast itself. All right, we got that. And we also want to set the lifetime of that capsule particle. So I'm going to set the lifetime random. So I'm going to set the lifetime of that, so that it's not always consistent, right? Blasters sometimes die faster, sometimes die slower. So we want to have a more a little randomness, so it looks a little more organic. So I'm going to set the blaster life to be about 0.3 seconds and 0.4 seconds. Just to begin with, just some random values I added. We can tweak those values as we move on. And right now it's just staying the same position, which really doesn't make sense. So I'm going to add some velocity to it, so it moves in a particular direction. So I'm going to set the velocity, set it up to a random value. So I'm going to add velocity. There's of course angular velocity you can add, and you can see that it is all 0, 0, 0. If you notice that the blasters are all looking at in the x axis, so I'm going to add some velocity in the x axis. So I'm going to add some velocity, I don't know, something to go between 50 and 80. So you can now see that the blaster is now blasting some capsules out. So if you are in need of medication, it makes more sense. But we are looking at plasma beams. So let's not look at capsules. So we will go and update the look of this particular particle. We're not really doing anything with the update particle right now. We are only updating the particles have already been spawned. We just want to change or mess around with the way in which the particles look. So I'm going to directly go to my output particle mesh. As you can probably see that the capsule itself is a little smaller. So I'm going to click on space. I'm going to set scale of the particle, and make it a little more bigger. So on this y-axis, I'm going to change the value to be something bigger. So make it 15. So, okay, so that's a lot bigger, but it's obviously facing the wrong direction. So let's also change the angle of the plasma beam. So I'm going to change angle, add angle block, and rotate this in, I guess, on the Z axis or Z axis based on where you are, by a little bit. So let's go to angle. I'm going to rotate it on the Z axis by 90 degrees. There you go. So now that looks a little better. So you can see that the blaster is flashing, and then a capsule gets shot out. That looks very not appealing at all. So let's add some color to it. So it looks more like a plasma beam. So I'm going to add color in the output mesh. Add color. I usually like the red blasters, so I'm going to change it to red. If you like blue or green or yellow, that's completely up to you. All right, so I'm going to change it to red. Of course, I need to change the intensity of it, so it looks a lot more like a plasma blast. There you go. Cool. Change the intensity. That's a bit too much. There you go. So now we have a cool looking flash, and you have a plasma beam that's traveling for a little bit of, whoa, that's a lot of time. It's like traveling for way long than what I expected. So let's maybe reduce the lifetime of it a little bit. So maybe right here, change it to maybe 0.05 to 0.1. No, that's still too much. 0.01, 0.02. 0.2. So as you can see, like as I'm, oops, why it's not? So I've noticed this quite a bit, where sometimes you just have to click on compile in order to make it compile. But there you go. Also make this lifetime a little lower. So 0.2, 0.03, compile. Oh, all right. So now that we have this, we have the blaster, we have the plasma beam also coming in. Let's name the system. Right click, name system. I'm going to call it plasma beam. Cool. We got that working. The last part is the more fun part, which is the explosions itself. So as I did previously, I'm going to chain these events together, right? So we want the plasma beam to end and then have the explosion come out. So I'm going to go to my update particle, click on space, and I'm going to add a GPU event as I did earlier. And I'm going to use the on die event again. But this time, instead of having only one particle, I'm going to create about 100 particles. So it's going to generate about 100 particles as soon as the blaster is dies or blaster is dead. So I'm going to again select event, click up, create a context, create a GPU event. Oops, not spawn. Create initialize particle. And then I'm going to create an output, not output, update. And then finally, I also, for the explosion, I really just need a quad output. So instead of creating a new quad, I'm just going to copy this output particle quad, Control C, Control V, and then just Control V is in Control C is the context, and I'm going to connect them together. All right, so let's look at the particles itself. Like, how do we want this to behave, right? So as soon as it ends about right there, I wanted to, first of all, inherit the same position as the previous block. So I'm going to hit space, inherit the position, so that it forms in the same place as the previous, as the depth of the other one. All right, that's good. And I'm also going to add some velocity so that it blasts in various areas. By the way, there's one more thing which I want to also talk about, which is it creates about 100 particles, and there's also a capacity in the initialized particle which talks about at any given point of time, how many particles can this particular system contain. By default, it's 128. I'm going to change it to about 10,000 because I really want, like, I want to have a lot of blaster effects, which you will see in just a bit. I'm going to leave it at 10,000. I'm going to add some velocity to it so that you can see it a lot better. So I'm going to add some velocity random, add some velocity random. And we'll add some velocity, something to go between 0, 0, 0. That's pretty good. And it has to go on the X and Y and Z based on some value that is kind of blasting towards you, because the blast usually bounces towards an object, right? If it hits the object. So I'm going to change it to about -2, 10, 10. I don't really see that much. That's because it's not really spreading as much as we want, and it also doesn't have a lifetime. So let's add a lifetime, because usually things need a life before you can start seeing it. So let's add a lifetime. Let's add a lifetime of, there you go. So it has a lifetime of 1, so it knows how long it's going to live. And you can now start seeing that at the end of the blaster, you can start seeing some particles over there. Lifetime is probably a bit much because the explosion just needs to be there for a few seconds. So I'm just going to make it 0.06. There you go. So it stays for a little less time than what we had earlier. I don't also really like the way in which it is spreading. So I'm going to add some bounds to the way in which, not bounds, but bounds to the way in which the particles are being generated. So I'm going to add some velocity and direction to be contained within a spherical volume. So I'm going to add position and direction, which is a block. Position, so not position, sorry, add velocity, not position, add velocity from, so you have a few options here where you have velocity, where you can change the add velocity depending on the speed, depending on the direction, but I'm going to add velocity to be in a spherical volume. So I'm going to click on spherical. And I'm going to make it the speed mode to be random. So I'm going to change the constant to be the speed mode to be random. And I want the center to be more offset. So about 27 on the X. So it feels a little more offset. And you can see this a lot better from this angle. And I also want the minimum speed and maximum speed to be changed, something between 9 and 16. So you can see now that this blast is being contained within a spherical volume rather than being on a flat surface, which is pretty good, which is exactly what we want. All right, so we have that going on. The next thing that blasts also usually do is they don't really go into space like that. They kind of fall down due to gravity. So I'm going to go back to my update particle. I'm going to add gravity. Add gravity so that the particle system really falls down. So that should add particle system. It's kind of falling down. Probably wanted to make it fall down a lot better, a lot faster. So I'm going to change the default gravity of -9.81 to be about, I don't know, -20. There you go. That looks a lot better. So it kind of blasts and then falls down as the way that we want it. All right, so finally, the look of the particle itself needs to be updated. So the look of the particle can be updated in the add color. So I'm going to leave it in the default particles. It's going to face the plane. And instead of adding a single color, which is yellow right now, I want the particle color to change color over life. So I'm going to delete this block. And I'm going to add color over life. And here, it's a pretty cool trick I want to show you here. So add life over color. So I'm going to select this color. On the top, that in the gradient editor, on the top is the alpha itself. So what is the alpha of the particular particle? And at the bottom is the color of the particle. Right now it's all white. So I'm going to change that. Click on this little ticker or selector and make it yellow at the beginning. Change the intensity up, crank it up a bit so that it feels a lot more sparkly or a lot more like a firework. There you go. And the end part, I wanted to have, select that, go here and make it a little more orangey so that as it dies, it loses a little bit of oxygen, I guess. And so it glows orange. All right, that looks good. And one cool trick I like about this entire particle system and this color is typically when there's a blast, right, there is a flash of white that happens because that's pretty much how explosions work. And you can add that kind of a flash, white looking flash by adding another pointer over here. I select that and I'm going to make it all white and crank up the intensity bit. So you can see there's a little bit of flash that shows up. It's probably a bit much. Yeah. And I'm going to drag this here and I'm going to change. Actually, I don't really care about this alpha that much. So right there. So now there's a white flash that shows up for just a fraction amount of time. And then you have the yellow particles show up, and then as the particles die, it turns orange. That's exactly what we want. All right, so that looks pretty good. And you know, I'm going to name this system. Right click, name system. I'm going to call this explosions. Cool. All right, so as you can see, there's a number of stormtroopers right here, and imagine there's like hundreds and hundreds of them. So having one guy shoot this blaster is not that much fun. So I'm going to line them up so that they are all blasting, you know, in a similar line. So I'm going to go to my original system, which is the Flash system, and in my initialized particle, I'm going to go to my initialized particle context, select space, and I'm going to change the randomness of where this blaster or where this plasma beams are being generated to be not from a singular point, but more from along a line. I'm going to search for line. I'm going to add this block called position line, and spawn mode is on is random. That's good. And I want the line position to be from 0, 0, 0 to be, and on the z-axis to be anywhere between 0, 0, 0 and 0, 0, 17. So that now the blasts are being randomly generated along this line. And I already measured that it's about 17, so that's how I know that number. So now you can see that it feels more like these guys are shooting it from from this particular line. That's pretty good. Also, I don't really like that there's like only one blaster at any given point of time. So let's change the spawn rate to be, I don't know, 1,000. There you go. So now you suddenly have a whole bunch of blasters that's being generated at the same time, and it also feels a little too predictable, right? Blasters are usually just going about randomly. I also want to change the capacity of this, because although it's generating about 1,000 particles in the spawn, the capacity of this is only so much. So I'm also going to change that to be a lot more. Compile. So it's going to have a lot more capacity of that, a lot more capacity in here. So you see a lot more plasma beams. Woo! There you go. Now the stormtroopers would never miss anything, which they usually do a lot. All right, and you can also see that some plasma beams are shooting up, some plasma beams are not, because the capacity of the initialized particle is only 10,000. So if you crank it up really high, and this is really the power of VFX Graph, because now you can literally have millions and millions of particles, and because they're all being generated in GPU, you can go crazy with the amount of blasters that you want, and that looks pretty crazy. So let's kind of, you know, tone them down, say make it 100. So this is the beginning spawn, that looks good. But let's say this looks too predictable and you want to have control over, kind of make it look more, say, randomish, or have more control over these kind of blasts. So what you could do is also, other than the context and the blocks itself, you could also create custom nodes that help you control these from as an external value. In order to do that, I'm going to select this green circle in my spawn context, leave it out. And here I'm going to add a sine wave as an operator. So the sine wave is a math operation. And now I have a sine wave looking blaster. It has an input and it has a frequency of 1 per second. And it goes anywhere between, and you can change the value to go anywhere between, I don't know, 100 and 200 every second, or not 2000, 100 and 200 maybe. So now it looks a lot more Star Warsy, I would assume, because that's kind of, whenever I've seen Star Wars movies, it always has a sine wave kind of a frequency to it. So that's kind of why I added the sine wave. And as I change the input, you can notice that it traverses the sine wave itself. You can also control the input of this over time. So I'm going to select this input, create a new operator. I'm going to call it, call the operator called total time, so that as the input itself is controlled by the total time that it has taken. So it feels a lot more random, at the same time has a little bit of sine wave frequency to it. And finally, let's say you're a technical artist and you have created this graph, but when you're handing it over to either a programmer or to an artist who doesn't really care so much about the VFX graph itself. And if you want them to still control these values, you can expose these values directly in the inspector. In order to do that, we're going to be using the blackboard, which I promised that I'll be talking about early on. So I'm going to select the blackboard. And in here, you can expose values of the VFX graph nodes, VFX graph values, I'd say, or values that you want exposed right from the inspector by selecting the blackboard, clicking on the plus sign, and you have a number of variable types. I'm going to select a float variable, and let's play around with the minimum and maximum value, because I have set it to default as 100 and 200, but maybe it has to be different, or maybe it has to be accessed programmatically. So I'm going to expose these values. I created a new float. I'm going to call it min value. And I'm going to add another float. I'm going to call this max value and expand that. I want to expose this value, of course. So as soon as I click on expose, you'll notice that it adds a green circle to it, which means that value is exposed, kind of a visual guide to that. Also click on expose on max value. And I'm going to set the default value to be, I don't know, between 40 as minimum and max value to be about 70. And there's two ways you can hook this up. One, you can just drag this node up and hook it up into minimum. You can also right click, create node, and now you have a new option here called property, which shows all of the properties that you just created in the blackboard. So I'm going to select max value and hook that property into my max value over here. And if I select the VFX graph in my hierarchy, go to my inspector, you'll now notice that there is a min value and a max value that's exposed right inside the inspector itself. And this means without having to go to my VFX graph, I can change these values to reflect. Woo, geez, that's a lot. Let's make it something like 400. Yeah, looks pretty good, I guess. And now you have all of these blasts, which is being externally controlled, and you have, and you can create a lot of cool effects. So that's about it. So what we have done today is really only scratching the surface of the VFX graph. There are tons and tons of visual effects that you can achieve using the visual effects graph. In fact, to inspire you, we at Unity have created a visual effects sample project in our GitHub page. And it contains a number of sample VFX. In fact, so let me just show that to you. So if you open up the GitHub page and you download the Vfx Graph Samples, there's a number of VFX examples that kind of gets you started. So for example, this is just a radar that kind of shows up. And this can be used in, by the way, Vfx Graph can also be used in universal render pipeline, which means you can also use it for creating augmented reality applications. This is my cool effect, Ellen hologram. I like this a lot. I originally wanted to do this to kind of have the Princess Leia hologram effect, but what this does is on the right-hand side, you see the hologram. If I click on play on the timeline, it mimics or copies the animation that's being played, and all while showing a hologram version of it using the Vfx Graph. You also have something like the Morphing Phase, where you can have a mesh and have it morph face the way you want it. You also have the Unity logo. We really like that a lot. It's just using an asset bundle, and then just bringing that asset bundle to create this Vfx graph. Or you can also have volumetric effects. And all of these VFX graphs are automatically available for you to kind of take a look at. So you can double click on the VFX graph asset itself. That'll open up the VFX graph editor, and you can play around with it, because it's a pretty complex looking one, but you get the idea. The idea is always similar. It has context, spawn, initialize, update, and output, and it can create external nodes or external operators to add into the mathematics of how the VFX graph is being created. So that's about it. That's all I had to talk about VFX Graph. And before I conclude this, and I'm of course I'll be sticking around to answer questions. There's two more things I want to also talk about before I forget, because I'm pretty terrible at forgetting things. Actually, pretty good at forgetting things rather. So during this, during this COVID crisis, in Unity, we are really committed to supporting our community. In fact, that's kind of why, I kind of hopped in as soon as I heard that Winnipeg Unity User Group wants to know about Vfx Graph, and I kind of hopped in and on this opportunity. So we're really here to support the community, and we, at this point of time, we have given complimentary access to Unity Learn Premium. It's available for 3 months. So if you're really interested in learning more about Unity and more about the Vfx Graph and all of the features, the Unity Learn Premium is available for free till June 20th. And Learn Premium, you can get exclusive access to Unity experts. You can have live interactive sessions and have on-demand learning resources and a lot more. It's super cool. At the same time, there's also a free course where you can learn to code at Create with Code. So Create with Code is one of our most popular courses where you can learn to code through fun games, which you create from scratch using C#. So if you want to learn more about C# programming, this is a fantastic place to go. So definitely check it out. So that's about it. That's all there is about Vfx Graph. That's all there is about what I wanted to talk about today. So now I'm open to questions, and really hope you enjoyed this session. I already have one question from Leslie, which is, I'm curious, what GPU are you running? I am running a NVIDIA GeForce RTX 2070. It's a pretty high-end machine, but Vfx Graph works on any kind of NVIDIA GPU, any kind of GPU. I've seen it run on a 1060 and whatnot. As long as your deployed device, be it mobile or be it a PC or a console, has a GPU, it should work just fine. All right, next question. Can you talk a little about controlling custom attributes in shader with data from Vfx Graph? Custom attributes in shader graph with data. Okay. So here, as you go to the quad particle, you can add a shader graph in the output particle quad itself. So you can select a Vfx graph. Sorry, so you can select a shader graph so that it behaves the way in which the shader graph itself behaves. So you can add those values in here. That's pretty much how you have custom shader graph. All right, next question. Can you have the plasma die and spark initialize when they hit walls in your scene rather than having a random lifetime? Yes, you can. So what you could do is, if you go to update particle or any context, you have an attribute here called collision. So collision lets you have collision with all of these kinds of collision boxes. You have like AA box, cylinder, plane, sphere, SDFs and whatnot, so that the blast then collide with something and then die rather than having a random lifetime. In the old particle system, the Billboard quad had many different rotation calculation options. What sort of controls do you have in Vfx Graph? Question from Graham. Billboard quad had many different rotation calculation options. I'm not sure what that exactly means. You can have these modes over here. So if you go to face, camera, plane options, you have different modes over here, which means you can have it face the camera plane, you can have the camera position, look at a particular point, look at a particular line. I'm guessing that's kind of what you mean. And you can have all of these options over here, with which you could play around with the quad, the angle in which the quad is facing. I hope that kind of answered the question for you. All right, there any more questions? So, okay, what kind of frame rate are you getting? Pretty good. Let's see. Stats. So, it actually looks very good. This is my frame rate. So it's about 87. And if I go crazy with the amount of particles, it kind of stays really well. within the range. So if I go back to my inspector and I crank it up, I've seen people go crazy with this amount of numbers. So it's 40,000. Yeah. Still stays pretty solid. Yeah. Yeah, that's pretty good.
Nice.
Yeah. Can you spawn VFX of vertex data of animated meshes? Cache debris. Yeah, that's, you definitely can. In fact, if you go to, let me open up this particular page because I have that open. Just a second, I'm just opening up the PowerPoint, which I'm not a big fan of, but there you go. This has links. This one, the VFX Toolbox is a fantastic place for you to go and look at how you can hook up Houdini effects and whatnot. So this is the VFX Toolbox. So you can have Houdini effects, bring them in, and you can have image sequences, blah, blah. And you can have point cache data, you can have volume exporter, all of those things which are already available inside Unity, and then make them behave the way you want it inside Unity itself. These are, you can probably take a screenshot of this, or I can just send it over to this chat. But this is a fantastic resource. There you go. There is chat. So I just put a bunch of links in the chat, and these are places where you can learn more about VFX, where you can, you know, there's a, you can, if you want general information about it, you can go to this site. There are visual effects samples, which I showed you earlier. This points you to the GitHub page. Vfx Toolbox provides with a lot of, I guess, Vfx Toolbox. And there's also a really good deep dive blog post that was written by one of the VFX artists, where it talks about diving deep into how each of these VFX samples were created. So it's pretty cool. How well documented is VFX Graph right now? It's very well documented. VFX Graph is officially out in production beginning in 2019.3. And so it's pretty well, it's very well documented. The documentation is fantastic. All right. Cool. Yep.
Did you have a question, Tamara?
Oh no, I'm good. I just wanted to say thank you for all the resources. That's so awesome.
Yeah, it's pretty cool. You can create some pretty wild effects. Ram raised his hand. In fact, one of the engineers that we have in India, he's a his name is Sharat Chandra, and he's a DJ when he's not really working with Unity, and he uses a VFX Graph to create these kind of visually stunning effects that kind of play with the music that he's playing. So it looks pretty awesome. So you know, there's a lot of use cases for this, especially when it comes to even, you know, live events and whatnot. So it's pretty awesome, and the performance is fantastic. I've seen people just use VFX Graph on the mobile devices and create some pretty awesome looking augmented reality applications using it.
All right. Sorry, I just want to make sure I could say my thing first. So just to quickly go back to the Billboard Rotation thing. Yep. One of the problems with developing VFX for example, VR applications is that when you have a billboard, it will face the stereo camera set well enough, but when you rotate your head, sort of like I guess roll out of tilt, yaw, and roll. When you roll your head, it would still rotate the billboard to face the camera, when in actuality you'd want it to like still stay properly oriented to the world.
Mm-hmm.
I'm wondering if there's any sort of control that you could have over those sorts of rotational features of the billboard facing system.
So there's two ways I usually handle it in VR. One, the easy way out is just use a mesh. So if you're using a mesh, then everything goes, it's in 3D. So the camera phasing problem goes away. But if you really want to use a quad in VR, I usually just write my own logic using the nodes. So I usually create a node and then create properties that make it rotate the way you want it to be rotating, or make it phase the way you want it to be phasing. I don't believe.
Okay, that's fair.
You know, I might be wrong. I might have to do a little homework on that, but that's usually how I've done. I don't believe that there is an inbuilt option in one of these blocks in VFX Graph that automatically makes it VR ready or anything, for quads at least. Yeah.
Okay. Thank you.
Yep.
Yeah, very cool. If I wasn't muted that whole time during the call, you would have heard me going, "Oh, wow, so cool," over and over.
Literally me. Yes.
Yeah.
Cool.
So,
one final thing.
yeah,
right?
wow.
One final touch. Yeah, there you go. I want to add a container to it so it feels a lot more Star Wars. There you go. Yeah. Yeah, there you go. That's about it. Yeah. So you know, I hope that you guys really enjoyed this this VFX webinar or user group, or whatever you want to call it. You know, I'm looking forward to seeing what else you guys are going to be creating, and you know, and if you hashtag, and if you feel like you want to share your VFX graphs, you can hashtag it on LinkedIn or Twitter or other social media. VFX Graph.
Oh, so cool.
And we have a lot of VFX artists inside Unity who often just keep looking or checking out these tags, and they retweet it or reshare it and give you feedback on it if you want to know about it or whatnot. So it's pretty cool. It's a pretty vibrant VFX community that we have inside Unity.